Good afternoon. My name is Pavan Pothukuchi. I'm a product manager with Amazon RDS. Thanks a lot for showing up today to learn more about Amazon RDS for MySQL. So we're going to go over a few topics around diagnostics, security, and migration best practices with RDS for MySQL. And along with me today, I have Søren Stoyner from Optaros and Antonio-Graeff from Titans Group. They're going to talk about how they're using RDS for MySQL in their environments. So thanks a lot, guys, for sharing your feedback with at AWS today. So Søren came from Romania, and Antonio came all the way from Brazil. So thanks a lot for braving through the time zone differences. OK, so wanted to quickly recap some of the features that we have launched so far in 2013. If you are a user of Amazon RDS, you probably know that we've been pretty busy through 2013. So the first thing here is the elephant in the room. I'm glad to be able to talk about it finally. We launched support for PostgreSQL today. And so we've launched a few cross-region related features in the past few weeks. So you can now migrate your database snapshots from one AWS region to another. And we also announced that we're going to support cross-region read replicas for MySQL in the coming few weeks. So in addition, we also launched a bunch of new features through 2013 with a few themes. So diagnostics, we supported the ability to download database logs through the through the AWS Management Console. And in addition, you can also receive notifications corresponding to critical database events in your environments. And we've launched support for identity and access management, through which you can control which users get access to which RDS resources. So we're going to talk about both these aspects in a bit. And we launched support for MySQL 5.6 earlier this year. In addition, we also launched a few replication capabilities that allows you to replicate from external MySQL sources to RDS, as well as vice versa. So in total, we have launched about 23 features across RDS this year, in line with some of the other services are doing. So let's start with diagnostics. So if you're an application developer, you know that it's extremely easy for you to develop loosely coupled multi-tiered architecture-based applications using AWS. However, if you're a DevOps engineer, you really don't want to end up in a place where your consumers tell you that there's an issue with your application. So you really want your upstream components to be designed in such a way that they're able to alert you at every step of the way if they encounter any issues. So AWS provides several tools for you to alert yourselves across these components. So one of that is CloudWatch. It's a monitoring tool that exposes a bunch of metrics across various services. And you can set up alarms on these metrics and can get alerted if there are issues. And SNS notifications is another functionality that a lot of AWS services are integrated with. And if there are specific events that you should be aware of, you can subscribe to SNS notifications based on the service supported functionality. In addition, a lot of third-party monitoring tools that you use today with your databases, web servers, et cetera, they all work seamlessly with AWS. And one important thing to know is apart from looking at monitoring from a siloed perspective across each of your components, you also want to connect the dots across the various components and look at the metrics in a holistic way. So Søren and Antonio are going to talk about how they do that in their environments. Here is a quick example. Say if one of your cache node fails, it's very likely that you're going to see some downstream impact on your database latency increasing. And you probably will have some upstream impact in terms of your HTTP requests queuing up. So being able to connect these dots and kind of figuring out what's going on from a holistic perspective across your applications is extremely important. So let's kind of zoom into the RDS-specific diagnostic aspects. So we'll start with CloudWatch first. So RDS exposes 14 different metrics to CloudWatch with 1-minute granularity. And you can set up alarms on these metrics to alert yourself of specific issues. So let's take an example of freeable memory. So this is a metric that tells you how much available memory you have. But one thing to keep in mind is MySQL allocates memory in chunks. So if you have a InnoDB buffer pool set to a certain value, only if you use it, the memory gets allocated by MySQL. So you'll probably see some level of constant decrease in freeable memory. And MySQL doesn't release it after it's allocated. So the allocation remains constant after a point. And so the thing that to keep in mind is freeable memory itself going down doesn't need to be an alarming thing. However, if your swap usage is going up along with your memory going down, that's when you should probably be concerned. And so here is another example where you have to connect dots across multiple metrics available to you to take specific actions. So in this particular case, you could either add memory by scaling your instance vertically up, or you could use read replicas and fan your read traffic to the read replicas. And there are a bunch of other metrics and specific actions, potential actions that you can take when you see specific trends within your database metrics. And another feature that we launched a few months ago is event notifications. So you now have the ability to subscribe to receive notifications corresponding to your database events that RDS generates. So in this particular example, we're creating an SNS. You have an SNS topic that you're subscribing to. The topic can have an email address. It can have a mobile number for SMSs, if you're familiar with SNS. There are several categories of events to which you can subscribe to: availability, backup, configuration changes, failover, etc. So in this particular example, we are subscribing to all failover-specific events. And you can specify a specific instance type, or you can specify a group of instance types, or all instance types. One particular way to configure this subscription would be, hey, I want to receive all failover notifications corresponding to my production instances. You can only select your production instances. And this is an example associated with events for a multi-AZ failover. So you can see that failover starts at 8:59, and then you have another event that gets generated at 46-second mark, and then failover completed. There's another event associated with that. So all these 3 notifications will be sent to you if you subscribe using that mechanism. So another way to diagnose database-specific issues, of course, is logs. And if you're a MySQL user, you should be pretty familiar with the types of logs that are supported by MySQL. So you have error logs, slow query logs, and general logs, each with different purposes and characteristics. So RDS launched the ability for you to download these logs directly via the management console through point and click. And you can also use RDS APIs to download these logs, integrate with your third-party monitoring tools to kind of make sense out of these logs. And Antonio from Titans is going to talk about how they use the logs and in conjunction with Splunk. So error log, RDS archives error logs every 5 minutes and retains them for 24 hours. So typically what happens in the MySQL environments is whenever MySQL restarts, error log is typically lost because it starts afresh. So with RDS, we archive the logs every 5 minutes so that you can go back in history and triage specific issues. So one example here could be, hey, MySQL doesn't, it's just restarting several times. And one example of log content could be MySQL is unable to allocate memory for the buffer pool. And this is something that could be because your memory parameters are not set right. And so there are cases where we have seen folks using InnoDB buffer pool size and setting it to a value a lot higher than the actual available memory in the instance. So when that happens, MySQL won't be able to allocate the memory and kind of runs into errors. And slow query logs. So slow query logs you can download from the management console, like we talked about. And you can also access them from tables. And it's important to connect the dots across all these metrics as well. So with respect to slow query logs, what you would want to do is, if you have specific trends with your CPU utilization hiking up, or your latency hiking up, you kind of want to understand what exact queries were running at that point in time to figure out if there's a application performance tuning that you will need to do. And like I talked about briefly, a lot of third-party monitoring tools work seamlessly with RDS. So any tool that doesn't require an agent to be run on the database instance should work. And these are a few examples. Security. Let's talk a little bit about the ways to set up security on RDS. And so AWS and RDS provides different layers of configuring security for you. Starting with the database itself, so you can configure roles, privileges, users on the database instance and the engine, and kind of control access to users. And so you have security groups through which you can control network access to your instances. In addition, we have VPC, through which you can set up your own network topology and have full control over the subnets and the routing rules that are associated with the VPC. And so we also have identity and access management, through which you can create users and assign responsibilities to these, delegate access to these users, and specify who has access to which AWS resource. And on the VPC side, just wanted to walk through a few best practices. So you always want to run your database instances in a private subnet, which means you don't want to associate an internet gateway with it. So you typically want to create your web servers in a public subnet and associate an internet gateway with them, but you would want to run your database instances in a private subnet so that you don't accidentally provide access to anybody else that you don't intend to. In addition, when you set up security groups in VPC, make sure that you have separate security groups for your web server infrastructure and separate security groups for your database infrastructure, so that you don't have rules that are supposed to go to the web server be applicable to your database server. For example, opening up to the internet. And another thing to keep in mind is you always want to connect to RDS instances through CNAMEs. So when a multi-AZ instance fails over, the underlying IP address of the DNS name associated with the instance gets updated to point to the standby instance. So you don't want to connect to RDS instances through IP addresses because they're subject to change. In addition, you also want to set up your TTL at the application level to a lower value so that after failover, the changed IP address gets picked up. And of course, use network level encryption for your applications. So I wanted to talk a little bit about identity and access management. So we touched upon it a few times in the past few minutes. So one best practice to keep in mind is do not share your AWS credentials across your organization. So make sure that you create users, IAM users within your AWS account, and then vend specific credentials to those accounts to your users. And you do want to tag resources. So tagging is a functionality that's available with RDS. You can tag specific instances as, hey, these instances are production, these instances are development, these instances are staging. And using tags and IAM users, you can delegate access to specific users. So my senior developers only get access to production instances. My QA team gets access only to the staging instances, et cetera. So data migration. So we talked a little bit about a couple of replication features that are available with RDS now, through which you can set up replication from your on-premises instances to RDS. And so this is one way to migrate your data either from EC2 or from on-premises to RDS. So the first thing that you would do is you have an application that is writing to an on-premises instance or an EC2 instance. So the first thing that you would do is create an RDS instance. And you would copy, take a MySQL dump of that on-premise instance. You would ideally want to do that on a read replica so that it doesn't impact your production instance. And then you pipe that MySQL dump to the RDS instance. And depending upon how large the RDS instance is, this could take several hours. And as you're establishing this baseline, your production instance is, of course, accruing writes and transactions. And so what you would do after that is you set up replication between your RDS instance and your on-premise instance through a couple of stored procedures that are available with RDS. And once the replica is all caught up with the delta of transactions, you can stop the writes on your master instance, point your application to the RDS instance. So we have a bunch of documentation that is available to kind of describe this process a lot more in detail. So I'm now going to turn over to Soren from Optaros, and he's going to talk about their RDS MySQL use case.
Thank you, Pavan. So we use RDS a lot when we are a digital commerce service partner. Obviously, we do a lot of architecting. We do a lot of building digital commerce solutions. And then what happens is that we actually operate these solutions, and we do hosting and support for them. This is not only your typical e-commerce cart where people just go in, they place something into their cart, and then they check out. We also support emerging models like daily deal sites. That to us means that we're covering a lot of very particular use cases for database usage and infrastructure usage. We've been using AWS since 2009, and we've been kind of the early adopters of RDS since 2010. And that basically has allowed us to take advantage of what RDS is providing, which is a managed database solution. Managed means that we don't have to spend as much resources internally, DBAs and other people that need to actually support these database servers. But there's also a compromise in the level of features that you have available. And I'm going to go into a little more detail about this later. So I've mentioned private event retelling. This is in order for you to get a better understanding of what kind of challenges we're facing. These are daily deal, private sales, however you want to call them, websites, where you have events that span 1 or 2 or maybe 3 days. And our customers, through their web stores, offer massive discounts and entice customers to purchase. These are invitation only, so if you get an email, you're into the event. If you don't, well, maybe next time. So then once you're in, you can reserve items, because this is another aspect that is enticing users to purchase, the fact that items you place in your shopping cart are only going to be available for a limited period of time. After that, they pretty much expire, so you have to add them to your cart again if they're still in stock. So at the end of the day, what happens is you are, as a web shop, you're pretty much DDoSing yourself, because you're inviting a lot of traffic starting at a certain, very specific point in time into your site. So you have to be very well prepared for that. Now, the way we run these events for our customers is just like you would run every other Cyber Monday. What happens then is that you're not going to probably get the same level of traffic as you would on Cyber Monday, but you get the exact same pattern of traffic. So the difference between private events retailing and normal retailing, at an infrastructure level, you don't really see it all that much because you have, like, your typical e-commerce architecture is exactly the same as you would in private event retailing as in regular e-commerce. You have your web servers, you have application servers, your database servers. So the application tires are pretty much all the same. What changes is the traffic pattern. So you see the calm before the storm for maybe 3 or 4 days in a week, and then all of a sudden you have this massive surge of users accessing your website. And then it dies down a little bit, and then this starts in the morning, like 9 a.m. Users come in, do their shopping a little bit, and then like 6 hours later, 9 hours later, it's 5 p.m., and they go off shift, and they do some more shopping. And then night comes, and then tomorrow morning again, maybe we send another email blast inviting some more users to the event, and you get the same thing again and again until it dies off at the end of the event. Now, obviously, we need RDS for a number of reasons, and one of those is that this is, in e-commerce, you are highly transactional. You must be ACID because you're not supposed to be losing any kind of transaction. You have to be highly available, and that's where RDS helps us with multi-AZ failover and also other advantages like on-the-fly changes to the RDS instances. I'm going to go into a little more detail on this later. But we're also seeing a very particular traffic pattern in the reads, in the way that the reads and the writes are happening. So for the writes, you have your sign up, add to cart, checkout, and you can use provisioned IOPS to help mitigate that problem. But for the reads, like catalog browsing, stock availability, these are things that you can't really cache because remember, we're doing the item reservation. So that's highly dynamic, that changes all the time. People are adding stuff to their carts expire, they're doing checkouts, and then your stock changes a lot. So you can't really employ a lot of caching there, so you have to go to your database pretty much every single time. And for that, we employ read replicas to be able to handle the amount of read traffic. Remember I told you that we're using RDS for reasons of efficiency. It's more efficient for us to have AWS manage the database tire, and then for us just to figure out how to make the application more efficient and have, if we need more performance, more capacity, we just do the API calls. And if you look at the traffic pattern again, the high to low peak ratio is huge. You can get as high as 100 to 1 in terms of number of requests and resource usage. And one other thing is that we have a very concentrated development team, a team of development and operations engineers, and we get a very high consolidation ratio when it comes to database servers and other resources as well, like EC2 servers. But in particular, with RDS, we're able to manage 50-plus database servers with only a team of 5 core DevOps engineers. In order to be able to manage all this, we employ a number of tools and techniques, and there is a list of them here. And this is by no means extensive. And I've told you before that we started with RDS very early, and that for us meant that we got a lot of the benefits, but also a lot of the restrictions in the beginning, because not all of the features were available from the start. So in time, we kind of had to build our own capabilities to do some things, like I'm going to go into detail on how logging was not really there in the beginning, so we kind of had to build our own solution. So I'm going to go through them one at a time. Now Jenkins, everybody thinks of Jenkins as their typical continuous integration build system, but we have started to view it pretty much as a build, not build, but job automation system. So everything that we do that can be automated we write a script, we put it in Jenkins, we expose it to the right team that needs to be able to perform that operation, and we use that. So remember I told you that we need to prepare those high traffic events. We know in advance when they start, so we have a heads up in order to be able to properly scale up. And then we do exactly that. Using scripts, we start the front-end servers, start extra cache machines, spin up read replicas. Now, you might say that we should be able to do the auto-scaling for the front-end servers using AWS auto-scaling. Well, it turns out you can't really do that because with that high surge at the beginning of an event, it's not only that you're not going to be able to spin up the instances fast enough, but you also need to warm up your load balancers, make sure that everything is in place. You need to warm up your caches. Your database servers need to be prepped so you're not reading off a disk. You should be also having your data set completely in memory. So knowing in advance and being able to automate allows us to be fully prepared when the event starts. So this used to be a lot more complex in the beginning, and we used to do it manually. But ever since we started automating, we can pretty much prepare for such an event. And remember, I told you, we're doing this every week like it were Cyber Monday. We start up more servers or less, depending on the predicted size of the event. But we do it just like we would on Cyber Monday. So in essence, what I'm telling you is that we're pretty much able to prepare for Cyber Monday in 30 minutes, if we need to. We're big fans of CloudFormation, and the reason why we're big fans of CloudFormation is that it allows us to take the automation a lot further than we would be using just the AWS API calls. Now, normally when you do changes to your infrastructure, you need to be able to replicate those changes across environments, because you would have your dev environment, you do something there, you test it out, and then you need to move it to your QA environment. Everything needs to be in place there as well. No, you're pretty much not allowed to have any differences, because then you're not testing what you're going to be putting in production. And then you need to migrate that into production. So what CloudFormation allows us to do is take a change, apply it on our development environment, and then take the exact same change, apply it on our QA environment, and then do the same with production. And what you're seeing here is an actual tool that we use that does stack diffs between what we have in CloudFormation already deployed and what we're planning on deploying, so we can see in a very visual way. And in this particular example, I'm changing the query cache size. So we're able to manage, for RDS in particular, we're able to manage parameter groups. Very important when you need to do some sort of database tuning. We're able to do security groups. We're able to do network ACLs, and Pavan has done a very good job of covering that as part of the security aspect of managing RDS. And we are able to do that in sync across all of our environments. Now, CloudWatch does a very good job at exposing system-level metrics that you wouldn't be able to access otherwise because you don't have physical access to the machines that are running your RDS managed database. So we actually take that data from CloudWatch and put it into Graphite, which is our central system for metrics. Why do we do that? You might ask me, why not use CloudWatch directly? Well, because we want to have other application level metrics, other system infrastructure metrics, and other why not business metrics within the same dashboard. So that gives us a centralized view of our environments and our application. And like Pavan said, and I'm going to go into a little bit detail right now, we're able to connect the dots pretty easily. So here's an example. You can see that I have Apache requests. I have CPU usage on my web servers. I have database CPU usage. I have database replica lag. And this is just an example. So in order to show you what I mean when I'm connecting the dots, top left there, I have a dip in my Apache requests. So why that happened? Having this holistic view of my application from the front-end tier to what I have, you can see that I have Varnish proxies there. I have Memcache. I have Redis in there in my stack. So I'm able to see and get a bird's eye view of what's going on in my environment. in this particular case, it turned out that I had a problem because one of my read replicas started lagging. My application wasn't really aware of what to do, how to properly behave in case it was connecting to a database slave that was lagging, and therefore it simply hung. We figured it out, we went there, we fixed the application, we put measures in place to take read replicas out of the application pool when we had this happen again. So this was a lesson learned for us, but we wouldn't have been able to easily detect this behavior had we not had this bird's eye view. Another tool that helps us a lot is Monyog. Now, this is a commercial application. It's becoming a very relevant in managing and monitoring MySQL databases. And the reason why it does that is that it not only keeps track of what's going on with your database, it's also able to come up with recommendations based on best practices. Now, if you don't have a dedicated DBA team that's able to keep an eye on your databases, remember, 50-plus database servers, you need something like this to keep an eye on them for you. So this tool is able to give me recommendations on thread cache, query cache, temporary table usage, binary log, the type of statements that I'm running against the database, and any optimizations that I would be able to achieve by running my queries in a different way against the database. So I've talked about this: monitors, alerts on key metrics, advice on best practices, useful diagnostics. So monitoring and alerting, again, we might have been able to do this with CloudWatch, but this is more than just the 14 RDS metrics that CloudWatch exposes. Now, you can pretty much alert on any system variable that gets exposed by MySQL. This is an example alert. In this particular case, the number of connections reached the critical threshold, 500, so I got an alert. This ties back into my paging system, so the engineers are able to execute when they get an alert like this. Pavan has mentioned the Percona toolkit. There are two tools that I want to mention in particular, but there are definitely others. There's a lot of them, and I think I've heard other people in other talks mention some other tools. The two I'm talking about in particular are the PT Query Digest. This tool is used to analyze your slow queries, but not only your slow queries, you can use it against your general log. And there used to be a time when you didn't have access to those logs using RDS. Now you do, so that's excellent. But if you want to be able to do this like real time, you're not going to be able to run the tool against a TCP dump on the database server. You need to do this on your application server. So you kind of go at the problem the other way around because of the fact that you can't access the RDS database. So you do the TCP dump, you get your dump file, and then you put that into PT Query Digest. And what you get at the end of the day is a list of queries sorted by frequency, the amount of time it takes to run them, and a lot of advice from the tool on how you could potentially rewrite the queries to get a better execution plan or a more optimal way of getting the data out of your database. Now, there are drawbacks to having a managed database service. One of them is that PT table checksum won't work. PT table checksum is a tool that is doing pretty much doing diffs between what your data is on your master and what your data is on your slave. Because of the way that replication works on MySQL, you may end up in situations where you have data drift. You don't want to be in that situation, obviously, but PT table checksum won't be able to help you with your RDS database because it requires special privileges. But That's not that much of a problem because we spin up and tear down our read replicas on the fly, pretty much every event. So we're less in a situation where we can have data drift. And now with MySQL 5.6, with crash-proof read replicas, we are less likely to end up in this kind of a situation. One other thing that you can have a problem with, and this is something that has happened to us so often, then I thought it's worth mentioning in there. Sync bin log is one particular parameter that you need to pay attention to. It can give you a lot of a performance boost because you're not going to disk on every bin log write on the master. So yeah, less IOPS in the database, great, no problem. But when you do the failover in RDS, given the way that the RDS failover is implemented, what happens is that your read replicas are not going to be replicating anymore. Again, not a problem with 5.6 crash-free replicas. Remember, I've mentioned that we didn't always have access to the database logs. So it was really hard for us to go back in time and once we had a problem, try and understand what actually happened there. Unless you kept an eye 24/7 on your process list, you had no idea what actually happened on your database. So we needed some way of logging or some way of gaining some more insight into what was going on into the database. This started up as a simple script that would go every 10 seconds and query the database, do a show full process list, show INODB status. But then it turned into a full-fledged app that would do that. And what's more, get the INODB variables and parse them out and put them into Graphite, save the INODB status, save the full process list into Amazon S3, and we would essentially get a time machine for our database. We would be able to go back in time, CSI style, and figure out exactly what happened at a particular moment in time. So here's what it looks like. This is a database server, and I'm looking at the INODB status. Remember, I told you that you can go back and forth in time in 10-second increments, and you can see the INODB monitor output, and then you can see your process list. Now, this is a particularly not interesting query because it's only been running for, it's only been started, but you can go in and see exactly what the query was that's run at that particular point in time. So what's next for us in terms of using RDS and managing RDS? We want to start managing read replicas using CloudFormation. This was something that was recently introduced as a feature in CloudFormation, the ability to manage your read replicas. And this was something that we weren't able to do before, so we had to go back to doing API calls using Jenkins. Now that we have this possibility, we're going to be able to just apply CloudFormation updates against our stack and do the event prep without having to go to the RDS API anymore. Using provision IOPS for lower latency. I mentioned already that we use provision IOPS to handle the read and write capacity, but provisioning more than what you actually need for your database can help you decrease latency. And in e-commerce in particular, where there have been studies on how web application response time actually influences conversion rates. The lower the application response time, the lower the page load time, the higher your conversion rate. Having lower latency on your web app actually means making more money. So that provisioning more IOPS to get a lower latency from the database actually means we're getting more value for our customers. We're looking to upgrade more environments to MySQL 5.6. We love MySQL 5.6. It's it has a lot better performance. It's a lot easier to manage than 5.1 and 5.5. So here's a feature request that we can probably get one-click upgrades from 5.1 and 5.5 to MySQL 5.6, because right now you have to dump all your database contents into a flat file or SQL query and then put it back up in a 5.6 version of your database. And with the cross-region database snapshots and other cross-region features, we're looking to do better disaster recovery. You don't want to be caught in a situation where your critical e-commerce application stops working because there's an outage. So you have multi-AZ, but as an extra measure of precaution, you want to be able to also do multi-region. So that's what I have for now. I'm going to leave Antonio to handle the rest of the slides and tell us more about how he manages RDS.
So before I talk about how we are using RDS at Titans Group, let me talk a little bit about what's Titans Group. We are a Brazilian company that provides value-added services to mobile carriers and landline carriers and internet service providers. We build, operate, and market products using our clients' brands in a model called white label. And we currently have clients in 17 countries and over 10 million users in our products. One of our most important systems is our carrier billing platform. We integrate with all the carriers, then we can charge the end users of our products directly in their phone bills or using their prepaid phone credits. And there are a lot of complex business rules involved in doing that and a lot of safeguards to prevent charging the users in the wrong way. And we have a very high volume of data flowing through our systems, and we have to make sure it's all safely processed and stored. The system cannot be down, or we just risk losing revenue. There are strict windows for charging users and even more strict service level agreements with the carrier. And because of the billing cycles of the carriers, we have a lot of transactions volume concentrated in just a few days in the month. Also, when you operate in 17 countries, there are a lot of different regulatory issues regarding logging, privacy, data retention, and we have to accommodate for all of them. When we started the system, we had a very simple and basic architecture. Just a load balancer in front of two application servers and a pair of MySQL servers in a master and slave configuration. And all of that running on an on-premise data center. We were processing less than 100,000 transactions a day, but the numbers were growing up fast. We didn't have any full-time DBA, and we're rapidly iterating our application to increase performance, and at the same time, converting it from PHP to Python. And we hit a lot of problems. We upgraded memory, CPU, and changed it to faster disks, SSD, a few times, but demand kept growing faster than we could remove the hardware bottlenecks. And obviously, it didn't help that we had a design flaw in our application since the beginning, and we were using MySQL to manage queues. Well, it was clear that we needed a more permanent solution. So we began making tests on AWS and comparing RDS versus running MySQL on EC2. And we were worried that RDS would not be a good fit for our read and write intensive application. But then, with impeccable timing, at least for us, AWS announced provisional IOPS for RDS. And with faster I/O, we would have a lot of room to grow. And with that taken care, we decided to go ahead and migrate. Our first few migrations took a lot of time and effort. It was a manual process and very error-prone. You had to dump the database you wanted to migrate, load the dump on RDS, and then replay manually the binary logs from the first database to keep RDS updated until you could switch your applications to RDS. And there was always some downtime involved in that. One of the tools we used in this process was PT Table Sync from Percona Toolkit. It basically compares two tables or two entire databases in a very fast and efficient way and find the difference between them and can make them synced again. You can use this to check if a migration was successful, or for some types of migrations, you can use it to directly copy the data between tables and databases. Today, with the new features of RDS, the process is much more easier. You just have to configure RDS to be a slave of the on-premises MySQL, and when the time comes, you just flip the switch or change the DNS to point to RDS, and it's almost instantaneous. After the migration to AWS and a lot of refactoring our systems, we now have a much more complex but scalable architecture. We have several RDS instances with specialized databases by function and are serving several million transactions a day and still growing fast. But now we are nowhere near hitting a performance bottleneck, and we still don't see a need to have a full-time DBA. RDS allowed our team to focus in improving our applications instead of focusing on keeping on operating databases. Our application can usually scale horizontally to accommodate spikes and increases in transaction volume. But if we need, it's also very easy to scale up RDS, raising provisioned IOPS and processing power and memory. Another thing that comes very handy are read replicas. They are very easy to set up, and we use them a lot for reducing the read traffic in the master, and also for doing ad hoc data analysis. And with several clients and products, tagging our instances allowed us to, in a very efficient way, getting a very clear picture of our costs, and that help us analyze the return on investment for each product and each client. When you are always improving your applications, we have to keep a close eye on database performance to make sure there are no problems introduced in the new versions of the applications you just deployed, or when MySQL suddenly decides to just not use an index. One of the tools we use to do that is New Relic. Some people from both our operations and development teams have New Relic dashboards open all day long. It collects data from an agent installed in the production application servers and with minimal overhead, and monitors a lot of aspects of our systems, including database operations. It gives us a graphic overview of what's happening with the database in any point in time. What are the most time-consuming queries? What's the database throughput? And what's the response time for each type of operation as selects, updates, and deletes. And it's possible to drill down to a specific query and see if its response time throughout a period of time is varying in an unexpected way. And allow us to see slow queries from the point of view of the application and not using MySQL slow log, and also shows an explanation in plain English of what's happening with the query, what index it's using, if any, and how many records it's scanned, and suggests ways to improve performance. Developer can identify a bad performing query, fix the problem, deploy the solution in a matter of minutes without ever having to access directly the production RDS instances. Another tool we use, and it's very important for us, is Splunk, which is a log management system. It receives applications and transactions log entries from our instances and makes them searchable. It's very easy to use RDS APIs to load slow logs and error logs into Splunk. And then, besides searching the logs, you can create alerts or see how a specific heavy query is performing over a long period of time. But there's a lot to be done yet. We have a lot of code data we have to keep for compliance reasons that don't need to be on RDS. So we are working in automating the process of migrating data to both S3 and Glacier for archival, and to Redshift for analysis. And that's just scratching the surface of what can be done in terms of data lifecycle management on AWS.